Hello again. I'm still Michael Steele, one of the Math 3 and Accelerated Math 3 teachers at Franklin High School this year. And once again, I'm going to be working through the Essential Skills Quiz model in order to help you sort of refresh some skills from the previous courses that might be a little bit rusty, but that you need in order to succeed on the Essential Skills Quiz. In this video, as with all the others, I'm going to focus on sort of talking through the ideas behind each problem, and then of course doing the problems for you and talking through sort of my motivation and what I'm doing each time, trying to refresh you on both vocabulary and the skill itself. In this video, we're going to be focusing on computing angles, specifically using an inverse trig function with a calculator as much as like by hand. So without further ado, this one's pretty quick. Let's dive in and start to take a look. So we're going to begin here with question number 8, and specifically 8a, and the instructions here are pretty relevant. They say to find the measure of the angle theta, and then they want us to state the exact and approximate answers for each to the nearest thousandth. So once again, there's sort of two elements at play here. We've got to know how to express this thing and use what information we're provided in the triangle to actually find the expression, and then we also have to demonstrate that we can evaluate that expression in our calculators. As with previous videos, I don't have a perfect calculator emulator that matches what many of you use, but I have a decent TI, and in this case the problem works just like it would on your calculator. So don't worry so much about like the skin of what it has, like what it looks like. Just worry about how it works, and I'll walk you right through there. So here we are with question 8a. We're provided a right triangle. You can tell it's a right triangle because of that angle symbol right down there. It's a right angle. And we're asked to find the measure of a particular angle. Now, of course, we've done special right triangles already. In fact, for me, it was like 15-20 minutes ago. But in here, we aren't going to have those special relationships where we can immediately go, oh, yeah, it's 45 degrees. We aren't going to have that in this case. We're just going to have sort of random lengths of legs on the triangle. And our job is going to be to figure out which one's which. How does it go? So in here, what we want to start with is sort of identifying which sides we have in relation to the angle we're given. And what that means is I'm thinking SOHCAHTOA. And I'm going to write SOHCAHTOA in 3 lines rather than 9, just to remind you sort of the purpose here. SOHCAHTOA is a way to remember the 3 major trig ratios, the principal ratios, sine, cosine, and tangent, and which side lengths they use, as well as the order, numerator over denominator. So for instance, SO means that sine of theta is going to be equal to opposite over hypotenuse. And yeah, I should probably give us a little bit more space here in order to do all of these. I sort of got excited and started to put them all together. But basically, sine is going to be opposite over hypotenuse. Cosine of theta, or cosine of an angle theta, we're just using theta as our angle, is going to be the adjacent over the hypotenuse. And then finally, TOA. TOA is going to be tangent of theta, and tangent is going to be the opposite over the hypotenuse. So before we do anything else in this triangle, although it is possible, I will note, to be able to use any of these 3 for any problem we give you, the fastest path is going to be identify which side lengths we have relative to our angle. So here's what I mean by that. We're looking to find the value of theta. So what angle is it? How many degrees does that have with those opposite sides, or with those sides? And then we have to identify what each of these sides is relative to that angle. So right here, we have the opposite side relative to the angle theta. And over here, of course, we are opposite the right angle, which means that we have the hypotenuse. So based on that, we're looking for the ratio that uses the opposite side length and the hypotenuse. And guess what? That's going to be sine. So my thought here is I want to calculate sine of theta. And sine of theta is going to be the opposite over the hypotenuse. So we know the sine of that angle is 10 over 15, which yes, it does simplify to 2/3, but we're not going to worry about that for the moment. You don't want to make a mistake since it's going to be a calculator problem. So with all that said, we need to figure out, sort of how do we get theta by itself? Like we sort of need the angle, and the angle's just like stuck inside there. So in order to do that, we need to use inverse sine. Basically, inverse is a way of undoing something. It's sort of the mathematical word for undoing things. So what we're going to do is we're going to sort of imagine this, and let's see if we can actually do it this way. So if sine of theta is equal to 10 over 15, I'll do it this way. If sine of theta is equal to 10 over 15, then we can imagine sort of inverse sining both sides. And again, it's okay if you just think of it as like you just do the inverse side of the other side. That's fine, but mechanically this is exactly what's happening. And that's sort of helpful to us for 2 reasons. First, the sine inverse and sine will undo each other. That's what inverses do. And then on the right side, we have our exact answer, sine inverse of 10 over 15, or 2/3, that would be fine as well. So basically right there, in fact, I'm going to go ahead and even write it over here, we have that exact answer that we were looking for. That's half the battle. It's, not the hardest part of the battle, but not the cleanest either. So there is our angle. So it is sine inverse of 10 over 15 degrees. But of course, that's not helpful. If someone asks you how many, what angle are we at this point, and you give them that, they're just going to give you a dirty look. Let's see if we can simulate that. Something like that. And do you really want to be on the receiving end of that? I'm not so sure. So having said that, we want to use a calculator to find the approximate answer. And as it says, we want to round that to the nearest thousandth. In other words, our approximate answer is going to be a reasonable number of degrees, like say 53 or 49 degrees, something like that. We want a degree answer. And of course, unless you are a super genius with this sort of thing, you actually need a calculator to help us with that. So here's my calculator. And I want to just punch in that exact expression. So of course, be careful though. If you press sine, it's just going to give you sine. It's going to take the ratio for a given angle. That's not what we're looking for. We want sine inverse. So we're going to press second sine. You can tell this calculator is kind of slow. And then we're going to put in 10 divided by 15. And then we'll be able to press enter. Now before I do want to give you one warning. This is not a thing that's going to necessarily be a problem if you're using your own calculator. But if you use some of the calculators you borrow from the classroom, depending on what other classes might use those calculators, you might actually run into this issue. You have to make sure you're in what's called degree mode. Like one way to measure angles is degrees. That's what we're going to use for a lot of this year. But by the end of the year, you'll actually be introduced to another way of measuring angles called radian mode. And there is even a third way of measuring angles called the gradient mode, although that's a little bit like nebulous. So we'll set that one aside for now. It's not something you're necessarily going to run into. But in here, we do need to make sure we're in degree mode so that the answer we get spit out is in degrees. In this case, we are. It says degree mode, just like a college-going student is in degree mode. We've got degree mode. I'm going to go ahead and press enter, and it tells us 41.810 degrees. So in other words, oops, change colors. Theta is going to be approximately 41.8, let's make sure that I have the right one, 810 degrees. And there are our exact and approximate answers. So again, it's using a couple different things in tandem. It's using SOHCAHTOA and our knowledge of those pieces. We're reading the right triangle to figure out which ratio or which side lengths we have in order to set up a ratio. We're using inverse trig, or inverse sine, inverse cosine, inverse tangent, and this problem is inverse sine, in order to find the exact value. And then we're just using the graphing calculator in degree mode in order to produce the approximate answer, our actual degree readable expression. So there we go. There is our first one. That will next bring us to question 8b. You've probably figured out the system here. I go from 8a to 8b, and then if things go according to plan, 8c. So here we are, 8b. So on the surface, it looks pretty similar to the last problem. The only difference is, of course, which side lengths were provided. On the first one, we had the opposite hypotenuse. Here, we have a different sort of pair of known side lengths. So once again, we're going to begin the same way. We're going to identify our angle. So we're working in that lower right-hand corner. It doesn't have to be that way. It could have been the other corner. But basically, we're working in that lower left-hand or right-hand corner. And now we've got to look at where we have relative. Well, first of all, 26 is clearly going to be the hypotenuse. It's still opposite the right angle, so it's going to be the hypotenuse. But 18 is right next to it. It's touching the angle, in fact, which means that we have the adjacent side. That means in our case, we have the adjacent and the hypotenuse side, and the adjacent and hypotenuse side point us to using cosine. So in this case, just like before, we're going to start with just the classic trig statement. The cosine of the angle theta is going to be equal to the adjacent side over the hypotenuse. So we know that cosine of theta is going to be 18 over 26. But of course, nobody asked you for the cosine of theta. So just like before, we are going to solve this for theta. And to do that, let me just give us a little bit more space here. Again, I like to do this as mathematically accurately as possible. Oh, it's not going to cooperate, is it? Oh, you think you're funny. Nice try. Ha, yeah, I beat you that time. Nice try, I got you. We're going to take the inverse cosine of both sides. Again, you don't have to actually show this step. I think you'll be able to jump right to it. But again, I'm going to be super rigorous about it as much as I can. So cosine inverse and cosine will undo one another. We'll be left with theta being equal to the inverse cosine of 18 over 26. And again, if you wanted to simplify that to 9 over 13, be my guest, but you don't have to. Like, you can just leave it as is. So in our exact case, we can put that exactly as is. Theta equals cosine inverse of 18 over 26. So now, having said that, though, we of course want the approximate one. We want to be able to describe this in degrees. So for college-bound students, like, describing things in degrees is huge. So we're going to go over to our calculator and, again, use the tools available. So once again, we are in degree mode. Very important. For me, that's right up here. It says DEG for degree. Next, I want to make sure I use inverse cosine. So I'm going to press second and then the cosine button to get the little cosine inverse. And then I'm going to put in exactly what we had. 18 over 26. Make sure I entered it correctly. Yes. Press enter. 46.187. So theta is approximately 46.187. And then we'll put degrees in there. So make sure I wrote that correctly. Yes. So there are our exact and approximate answers, respectively. So again, nothing really different here except for the fact that we're using cosine and thus cosine inverse instead of using sine and sine inverse. So now let's see. Before we go on to the last problem here, so while I change colors, let's think. We did an inverse sine problem. Then we did an inverse cosine problem. Does anyone want to tell me what they think the third problem is going to be? Dun, 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 dun. Yeah, I think we got it. But let's pretend like we don't know this for sure, and we're looking at it with fresh eyes, just in case you're the person who's like, I can do the first two, but not the third one. Let's tackle this. So where do we begin here? Just like before, we want to start with the angle that we have available to us. So they gave us the lower right-hand corner angle. Maybe it's going to be that way on every quiz. I'm not sure. Like, these were all written freshly this year, so who knows for sure. But we're starting with the angle theta, and we're looking at the sides relative to it. So basically from here, we have the opposite side. And from here, we also have the side touching it, which is the adjacent side. So we want the ratio that has opposite and adjacent. And oh, wow, I never would have ever predicted in my wildest dreams that it was going to be tangent on the third one after doing sine and cosine on the first two. What? But here we are. But against all the better judgment, they said it couldn't be done. We did it. We have tangent, which means we can write out the ratio here. Tangent of theta is going to be equal to opposite over adjacent. Finally, a ratio that doesn't simplify too, so there's no ambiguity. But beside the point, we know tangent of theta is 22 over 43, but nobody wants that. Nobody asked for that. So let's do this the same way we had before. If tangent of theta is 22 over 43, then we can get frustrated when the thing doesn't cooperate. Sorry. Hold, please. There we go. We can, just like before, take the inverse, in this case, inverse tangent of both sides, and find our exact answer. So on the left side, the tangent and tanverse and inverse, tangent inverse, tanverse inverse, tanverse inverse, the tangent inverse and tangent will undo one another. We'll be left with the classic theta. And then on the right side, we'll have tangent inverse, which, by the way, you'll later learn has another name. It's also called arctangent, but for us, we'll just call it tangent inverse of 22 over 43. And congratulations, we have successfully found our exact answer. And our day would be done were it not for the fact that we're supposed to write out the approximate answer as well. Thankfully for us, we have a friendly neighborhood scientific calculator emulator that has a 90-day free trial, so I didn't have to pay another $200 for a calculator emulator. I have this one down here that also does it. So what are we going to do? We're going to first make sure we're in degree mode. So I see DEG. That's degree mode. So that's what we're looking for. Second, I want to use inverse tangent. So I'm going to press second and tangent to get tangent inverse. And then I'm going to punch in 22 over 43. When I press enter, it tells us the angle is 27.0955, which is 27.096. And just make sure I didn't mess up a decimal there. Looks like I did not. So after all of that, there are our two answers. And guess what? It's been a real hoot. But we are completing the computing angles question from the Essential Skills Quiz model. which means that I can take a short break. I can take a break, actually. I think I have 3 of these left. I've saved all the graphing ones for later. That was sort of my mistake. But in any event, we are complete here. Hopefully that gave you a good, wide exposure to a lot of the different ways that we can ask you questions. Basically, you saw the 3 that are here, asking you questions about inverse sine, inverse cosine, or inverse tangent, and all it comes down to is, of course, setting up the ratio and recognizing, of course, which side lengths you have relative to your angle to set up that ratio. So having said that, hopefully this was informative and useful for you. If it wasn't, don't tell me, blah, blah, blah. I can hear you. Because also I'm in the past. So in any event, thanks for watching. Have a great night.